welcome everybody. So today's webinar is dedicated to the update of oil and gas supply in ecoinvent version 3.9. My name is Lucia Valsasina. I'm a project manager at ecoinvent. I'm here with my colleague Karl Wadenbo, and today together with us we have Niels Jungblut from ESU-services. You will see here in the slide also the Christoph Miley, who was with us yesterday in when we had the same webinar at a different time. So I will be providing you just a quick introduction to how this webinar is going to work. Then I will provide a quick introduction, also an agenda. So you're all muted, and you have the possibility to interact with us and ask questions in the question tab. So in the go to meeting window, you should see a questions tab. So please do use that to ask us questions. We will have a Q&A session at the end of the presentations. So we will wait to take the questions at the end unless there's something clearly unclear or some technical issues in between. Otherwise, we will wait for the Q&A session at the end, but I will really encourage you to ask them throughout the webinar as they come to mind, so that we can also then better organize the Q&A. Any question that will remain unanswered, we will follow up by email. And of course, any further question you might have after the webinar, including not only questions, but also discussions you would like to have with us or with our ESU-services, please do contact us at support@ecoinvent.org, and we will of course then redirect you to and coordinate to provide you the best answer to your question. So just looking at the agenda, I will give you a quick introduction to the ecoinvent database. I will then pass the word to my colleague Karl, who will give you a brief introduction to the topic, and then we will hear from ESU-services, who will walk us through the underlying LCIA study for this update, and then Karl will take back the word to then explain you how this update has then been integrated into the ecoinvent version 3.9. So ecoinvent, the ecoinvent Association is a not-for-profit association dedicated to promote the availability of high-quality data for sustainability assessments worldwide. We were founded by 5 Swiss research institutes: ETH Zurich, EPFL Lausanne, PSI, EMPA, and Agroscope. We're a team of 36 people between LCIA and LCIA experts, our software development, and of course, sales and communications team. You know us best as the publisher of the ecoinvent database, but we are also a service provider. So we engage in projects related to data interoperability, data creation, data handling, analysis and distribution, as well as capacity building and awareness raising on these topics. The ecoinvent database is a global library of human activities, which include thousands of processes along different industrial sectors. It's updated every year. It's trusted by over 8,000 licensees in over 80 countries, and is compliant with the ISO 14 series. So as just said, the database is a library of human activities. There's 19,000 activities and around 4,000 products in the current version 3.9. And this is covering all regions in the world. And as said before, we are covering different sectors and different industries. So from agricultural processes, transport, end of life, machinery, metals, etc. So with this, I would like to pass the word to my colleague Karl, who will introduce the topic.
Thank you very much, Lucia, and hello and welcome also from my side. So I will just give this very brief background to the update before handing over to Niels Jungblut at ESU-services. And Yeah, the background is really that the data on the supply of crude oil and natural gas in ecoinvent up until version 3.8 had clear limitations in terms of geographical coverage, and also the data varied in time representativeness. So the goal for the update for 3.9 was therefore to include more of the main producers of crude petroleum oil and natural gas around the world to better reflect the global supply situations, but at the same time improve the data and modeling consistency across these regions. And the update should also then incorporate the most recent data on key aspects like gas flaring, venting, and fugitive emissions of natural gas during production, transmission, and distribution. And finally, there was also a need to update the existing supply mixes available in the database. So with that, I would like to change the presenter to Nils Jungblut, who performed the LCIA study that formed the basis for this update. I hope Nils is now able to share his slides. Perfect, we can see it. Thank you very much, and the floor is yours, Nils.
Yes, thank you very much, Karl and Lucia, for inviting me for presenting this work here, which we did over several years. My name is Nils Jungblut, and I'm owner and manager of ESU-services, and these updates have been made together with Christoph Meili and Marisa Bussa, who are also working here at ESU. Some short words about us. ESU-services has been founded in 1998 as a spin-off of the ETH Zurich from the group of the ecoinventar von Energiesystem originally, which has developed the first version of a former ecoinvent database in Switzerland in the 90s. Yeah, we have clients from industry, NGOs, administrations, and universities. We are an LCIA consultancy doing LCIA case studies, providing screening LCAs, and we are also elaborating lifecycle inventory data, as in this project with several databases. We are also reselling the CIMA-Pro software in the German-speaking market, and we are providing review and validation for LCA case studies. At the moment, we are 5 people working here, and we are covering all economic sectors and more than 350 projects related to lifecycle assessment. Some words about this project I'm presenting here. The aim was to have a full update of the lifecycle inventory data for crude oil and natural gas extraction and their transportation to the gate of oil refineries or to the local gas distribution network, so providing these basic fossil fuels for further processing and use. The reference year of the study is 2019, so the latest year where we had all statistical data together. The aim was also documentation of these harmonized lifecycle inventories. First, they have been documented in the EcoSpolt 1 format and in CIMA-Pro, and in this project they have been transferred to the EcoSpolt 2 format for ecoinvent. In order to achieve consistency for several countries, we use global data sources where this is possible. For example, for the trade flows, for key environmental data, and for methane and flaring emissions coming from these things. So that's a big change compared to the older inventories, where a lot of different data sources have been used and mixed together, and that was more a bottom-up approach. Now we use more this top-down approach to achieve consistency. The data are the basic for the update of several LCA databases, like the UVEC and KBOB data published by the Swiss authorities, and the ecoinvent 3.9 data, which was a specific goal of this project. The updates have been made over several years. So the first projects have already been made in 2018, together with the Swiss Federal Office for the Environment and Energy and the Swiss Oil Association. Later on, we made a project together with the Office for the Environment and the Swiss Gas Association to harmonize the data for the gas. We had also several smaller projects together with different organizations, and now this project with ecoinvent extending further the scope. The original scope was more the Swiss supply situation. Now we also looked on the global supply chains of oil and gas. Here I present some insights for the first stage of production, the extraction of oil and gas. We cover 27 countries. For each country, if we separate for onshore and offshore extraction, if it is the case, of course, there's some countries only doing one or the other. We looked at these data as combined data sets for crude oil and natural gas extraction, because the statistical sources normally do not allow to make separate inventories for the two products, and often they are produced also in combined production. The allocation there is based on the energy content of the two. As said, we are focusing on global data sources which allow harmonized inventory. We use country and resource-specific data for flaring and methane, mainly from the World Bank and the International Energy Association. We have region-specific data for the use of resources, water and energy, published by the IOGP. This is the Industrial Organization of Gas, or the Industry Association of Oil and Gas Producers, so a global association collecting data from this industry, and they publish the data in per world region like Africa or Middle East. In the project, we used also an adjusted energy content for the allocation for the different resources and products. According to the used statistics of BP, British Petroleum, the World Energy Outlook, which is also a very important statistical source for seeing the production data and the global trade data for these products. And another relevant change was you might know if you use ecoinvent data that often the ozone depletion potential is mainly influenced by oil and gas production. Where all these ozone depleting substances are phasing out. The oil and gas sector was one of the last sectors where it was allowed, but also there today we assume that there's much less emissions of these ozone depleting substances, and that they have been replaced with other substances. The selection criteria for the countries were that we have a good representation of the mixes for Europe, North America, and the global mix, and Switzerland. We selected all countries with a share higher than 2% for the these mixes in these regions. So, and then some additional regions have been added, like for the Latin America. 3 more countries have been added, and for all of these countries we modeled the data sets for oil and gas extraction. So at total we cover 86% of the global energy production from crude oil and natural gas. In this map you see the most relevant countries, of course US and Russia are the most relevant countries. And here on the left side, you see the share for the global production of oil equivalents, so the sum of oil and gas for the different countries for which we modeled the oil and gas extraction. Well, you see that the US have about 20% and Russia has about 15% of the global production. Now to the one relevant change, it's the source of natural gas emissions. So far, these emissions have been more modeled in a bottom-up approach, that we had data from single leaks, for example, where methane was leaked out of a pipeline or so. And this can also be reported by companies. Today, we know that there is also methane coming from somewhere from the earth in these oil and gas fields. So natural gas emission means emissions of unburned natural gas to the atmosphere. And of course, for the climate change, seeing mainly methane is a relevant pollutant. And yeah, so this was an important theme for the update. To switch this a little bit. Yeah, if industry reports about these emissions, they mainly look on technical process change due, for example, insufficient flaring or no flaring available, accidents and leakage. And as I said, these emissions can also come directly from the earth. For example, if you have fracking, that there's an emission somewhere in the field and not related to a technical structure. Today, we can measure these emissions with satellites. And this was, of course, not possible at the last relevant update in the beginning of the 2000 years. And these satellite measurements show that emissions are much more diffuse and less connected to the flaring rate than expected by the industry. You might also have heard about this Nord Stream 1 and 2 accident or rupture, and immediately it was possible with satellites to measure the amount of methane coming from these sources. Well, for this, in the last years, we looked at different sources and we changed also the sources from update to update. What is common to all these sources of scientists who have evaluated the satellite data and who have assigned them to up and downstream activities of the oil and gas extraction is that the emission rate is much higher than previously assumed and assumed by the industry associations. So the IOGP reports the global emissions in average to be about 0.6%. No, 0.06% of the total extraction. And now the different sources, they reported much higher, a factor of 10 higher, in the range of about 1% of the extracted oil and gas are emitted in the form of methane to the atmosphere due to the disease activities. We evaluated these different literature sources and finally took the International Energy Agency statistic because they differentiated between upstream and downstream emissions, also between onshore and offshore emissions. And it was possible to relate this data for the reference year to the global production statistics. The final global emission factor is then 0.8 or 0.9% of oil equivalents are emitted as methane. Good. Well, that's the relevant change to the extraction. I think there are, of course, also other data for energy use and so on have been updated as well, but the changes are not so dramatic or relevant if you look at the final data. Then we made inventories for the transport of crude oil to the refineries. We looked at the supply mixes for Europe and Northern America, Switzerland, the global situation. Of course, there might be quite different ways and journeys. So we just took from one country to the other. We assumed one port of origin and destination for the journey. We made an extrapolation for the share of analyzed country to, at the end, have 100% of oil in the mix. And yeah, there were no update on minor issues like the infrastructure and the direct emissions from transportation. And there is now one data set modeling the average supply to a refinery of crude oil in order to easily handle this for further updates. Well, then also for natural gas to end consumers. We updated the data. Well, we have low pressure supply mixes for about 15 different countries and regions. The energy demand and leakage rate of pipeline transport, regional and local distribution have been looked at. We consider also the offshore pipeline from Russia, Downstream 1. We updated the data for the fire suppression agents, which are relevant for this ozone depletion potential, and Hello 1211 has been replaced with other hydrocarbons. We included the energy demand and the emissions of liquefaction and evaporation. So this big theme of now switching the European gas supply from pipeline support for delivery via pipeline and switching to LNG tankers, and this putting or making LNG and reliquefying the gas. This has also quite an important energy use and loss so of energy content of the fuel. Well, we include also fuel consumption and emissions of LNG carriers, but this was not yet included in the updates released with ecoinvent 3.9. The reports describing this, there are 3 reports, one for each of the stages I mentioned here. They are available on our homepage. Also, older versions of these reports from the last 5 years are available on this page, and you can download it here and look at all the details of the modeling. And well, in summary, it can be said, and we will see this later on if Carl shows the results, that the full methane emissions need to be accounted for all processes from the oil and gas supply chain. You know that it was also a big theme in the last IPCC conference, and that there is now also this International Methane Observatory by the UN, which will also ensure that there will be good statistical data available for this. Industry measurements cannot show this full methane picture because they normally do just look at the technical structures. The changes are mainly relevant from the cradle to gate analysis, for example, for plastics and chemicals. If the combustion of the fossil resource is not yet included, the combustion, of course, still will remain the major source of CO2 emissions in the life cycle from cradle to grave. Changes are also relevant, for example, for relative comparisons between fossil-based products with bio-based products. And well, the situation, of course, changed again dramatically in the supply situation, at least changed dramatically for Russia and the Ukraine, with a change in supply mixes to Europe and changes in the global distribution of these oil and gas products. While we, in a further update, we might also look at these increased flaring rates in Russia due to the missing downstream options and the rupture of the Nord Stream pipelines, which also emitted a lot of methane. But yeah, that's not yet included. So this theme will remain an interesting topic for updates. Here again, all the organizations who put more or less money into these things, but what I presented here, it's only our personal conclusions from all these studies and the updates made. Good. This was my presentation.
Thank you, Niels. Really appreciate you sharing this with us, even though you're obviously feeling a little bit under the weather, but you made a very brave attempt to get through that presentation nonetheless. Thank you very much. I will take back the control, and I hope that should be back now. So just to recap or to summarize a little bit before we go into more the details about how this update was implemented for ecoinvent version 3.9. We are here looking at an update covering production, long-distance transport or transmission, and the distribution of crude petroleum oil and natural gas. So maybe it's also important then to highlight what was not included in this particular update. So we did not here consider production and further processing of natural gas liquids, nor did this update change anything in the petroleum refinery operations in the database. We also haven't updated the regional distribution of refined petroleum products, nor any blending of biofuels in neither in the liquid fuels nor in the gases. So also the downstream uses of natural gas, so be that for electricity or heat, or hydrogen supply, or for chemical feedstocks, they were not considered within this update. Instead, they are being addressed in separate data update projects, either 4.3.9 or for the next release. And the goal of this webinar is to provide an overview of the implementation of this data and to share some of the key results. And please be advised that we will stay rather superficial, so detailed descriptions of the changes made, as well as a deeper analysis of the LCIA score changes. That's provided in Chapter 6 of the 3.9 change report, which is available on the ecoinvent website. So, as Niels already indicated, the update for version 3.9 increased the data coverage for production of oil and gas to a total of 27 countries. And taken together, these countries represent approximately 90% of global production of petroleum oil and nearly 80% of natural gas output. And that is for the reference year of 2019. And all country-specific extraction data sets in 3.9 have been created now with a common approach, so relying extensively on data sources of a global scope to ensure a high degree of consistency between geographies throughout the whole database. And the production of crude oil and natural gas is modeled as an average combined production data set, as Niels also indicated before. So this is only then distinguishing between offshore and onshore operations for each country covered. So this means that the neither associated versus non-associated gas production, nor conventional versus unconventional oil or gas extraction is considered separately. And let's now have a look at how these supply chains actually look like in the database. So the supply chain modeling for crude petroleum oil is quite straightforward, with the production linked to the market activities in the database before then reaching the petroleum refineries. And there's one exception here, and that is in Brazil, where the domestic oil production is directly linked to the petroleum refinery in that country. And the transport requirements as weighted averages based on the location of production and of the demand in pipelines and tanker ships are also then added to this market activities. So this map on the left-hand side of the graph of the slide illustrates the 27 producing countries covered by the update. And on the supply chain, the supply side, the demand side, we have introduced regionalized consumption mixes for Switzerland, Europe without Switzerland, and the region of North America, again, representative of the supply situation in 2019. And the rest of the world mix was here derived as the difference between global production and the sum of supply to these regional datasets covered in the database. So that is the share shown here in the graph on the right-hand side, shown in purple. Moving on to the natural gas supply chain and implementation in the database. This one is a bit more complicated than that of crude petroleum oil. And I won't go through the details, but one of the most important aspects here are that the natural gas can then be supplied either directly from domestic production with seasonal storage, if a country has own production, or through imports, and then either via long-distance pipelines or as liquefied natural gas. And a part of the energy required for these processes is provided by the gas itself. And this is modeled in the database with these data sets called natural gas burned in gas turbine. And that's modeled both for the supplying and the demanding geographies. And this is then to make sure that the origin of the gas combustion, combusted for internal energy purposes, also corresponds to the gas being handled in the process. So on the supply side or the demand side, the regionalized supply of natural gas at the high pressure level in ecoinvent version 3.9 covers 45 geographies. And out of these, 23 market activities were updated for 3.9, representing consumption mixes, of which 12 countries now also have supply down to the low pressure level. And 18 mixes consist of gas from domestic production only. So this is then to also have a gas supply in the producing countries included in the update. And as for petroleum, the rest of the world mix was derived by subtracting the combined supply to these markets from the global production. Oh, sorry, that was what I just said. Let's have a look at what I just said on the map. So this is what the status of regionalized supply of natural gas, again at high pressure level in 3.9 looks like. And maybe just to mention, there are 3 market activities, that would be for Brazil, Austria, and Japan, where the supply mixes were not updated compared to version 3.8, but all of the other ones have been updated. So, given that the supply of oil and gas affects virtually all other sectors in the database to some extent, we would here just like to share a little bit about how the LCIA results have changed with this update. And the focus in this webinar is placed on the relative changes for the EF recommended methods, and more specifically also on the global warming with global warming 100-year potential. And a more detailed analysis is available in chapter 6.6 of the change report as well. So in this first chart, we compare the relative changes in scores for crude petroleum oil supply between 3.8 and 3.9 for the allocation cutoff system model, using all of the EF recommended impact categories. And for this, the 4 markets for petroleum in 3.9 are being compared to the single global market for petroleum available in version 3.8. It's a pretty detailed and perhaps tiny font, so we won't be able to go into all of the details here, but I would just like to highlight and point out a few of the bigger changes that we can observe, and also just mention a little bit the underlying drivers for those changes. So let's start with the impact on climate change and also on photochemical oxidant formation. And this is clearly driven then by this increase in methane emission intensities that were included in this update. And for the case of global warming potential, of course, the flaring intensities also have a big contribution depending on the country here as well. And I will come back to why the supply in Switzerland, which is indicated here with these blue bars, stands out from the other geographies in my next slide. The impacts on human toxicity for cancerogenic substances are very sensitive to the input of the bore well. So this is due to the generation of drilling waste and other infrastructure requirements, which have generally increased with this update. And perhaps in contrast, the non-cancerogenic human toxicity impacts are instead influenced by the water discharge and the pollutant load modeled for this water. So these are quite sensitive to these changes in the inventories. And finally, I just want to point out what also Nils mentioned before, that the changed modeling for the Halon 1301 emissions for fire suppression, which is now considered only in offshore operations to some extent, of course, have led to quite a big, in this case, negative change in the impact on ozone depletion from these supply chains. So how do these results then compare to those of other sources? And I will just here give a quick comparison to one of the most well-known studies on the subject of crude petroleum oil supply and the carbon intensity of those supply chains in recent years. So that's Masnadi et al. Study from Science, published in 2018. So this is obviously not a perfect comparison because there's some differences both in reference year and in the scope covered here. But looking at the 27 countries for which we now have production in the ecoinvent database and the climate footprint of these production, we see a generally very good alignment, with some exceptions. I will discuss them in a second. So just to give you a bit of a reference, this is the Masnadi study is using a bottom-up modeling approach, a very sophisticated bottom-up modeling. And this is the approach that is very similar to what is currently being used, for example, by Climate Trace, who just published their most recent emission inventories last week, together with the COP27 meeting. So we see that 3 countries, Algeria, Libya, and Venezuela, so that's DZ, LY, and VE, they stand out in one direction with much higher carbon footprints in ecoinvent. And this is most likely due to the way that IEA accounts for various governance indicators, like, for example, the rule of law, in the country scaling factors that they apply to derive the country-specific methane emission intensities. And with more than 20% of crude oil import to Switzerland supplied from Libya in 2019, we now see the reason why the change in score for this particular market was much more pronounced than for the other markets available in the database that we saw in the previous slide. And in contrast, the study by Masnadi et al. Indicates much higher climate impact of petroleum production in Canada, CA, see here in the left part of the graph. And this suggests that we might not yet capture the full burden of unconventional oils, such as extracted from the oil sands in Alberta. And how does these changes then affect the downstream uses of these products? So in this waterfall diagram, we start from the petroleum supply. And again, this is for climate change and relative change between version 3.8 and 3.9. So starting from the petroleum supply, we see the effect on the main refinery outputs. So diesel, fuel oil, kerosene, naphtha, LPG, and petrol. And then I've included 3 end uses, and with the main hotspots for the full life cycle of fossil fuels, at least without carbon capture and storage, the hotspot is still very much at the stack or at the tailpipe. We here see that the updates result in approximately 10% higher impact scores for the global warming potential at the 100-year perspective. So this is to give you a sense of how much the change in supply alters the overall score when these fuels are used for energy purposes. Moving on to the impact of natural gas. we start with some European countries and again across all of the EF recommended methods. And the updated natural gas markets are influenced both by the changes in the production, so in the upstream supply, but also in the changes of the supply mixes compared to the 3.8 version. But the results generally follow the same patterns that we saw for the crude petroleum oil. Some impact categories, though, they see larger differences here. So, for example, the freshwater ecotoxicity, which is the third one from the left. And this indicator is driven by the input of borewell infrastructure, again, due to drilling waste. And this has increased across nearly all geographies with this update. And I would also like to point out that several of the other indicators with high relative score differences, like material resources, for example, are also very sensitive to the infrastructure requirements and explain this figure to some extent as well. So leaving Europe, we take the same comparison here for gas supply in Brazil, Canada, and the US. And the general pattern is by and large aligned with those discussed for Europe. But I would here like to focus a bit on Canada, which clearly stands out for 3 indicators. And here it's really important to know that the natural gas supply in Canada was up until version 3.8 modeled as a market group made up of provincial markets for natural gas in Alberta and in Quebec, representing 95% and 5% of the total annual volume, respectively. And the supply to both markets in 3.8 was completely covered by the production in Alberta, so by own production. And the new market activity for natural gas in Canada in version 3.9 is supplied to 88% of domestic production and the rest by imports from the US. And the largest differences to 3.8 occur now for indicators that are very sensitive to aspects like the infrastructure requirements, the flaring emissions, and also the background electricity mix for these data sets. So finally, let's have a look at another downstream use, and in this case, it's all of the chemicals available in the ecoinvent database. This represents the change for global warming 100 years in the chemical sector, again comparing 3.8 and 3.9. And of course, this figure doesn't capture only the update on oil and gas, but also all the other changes made for 3.9, all of it in combination. And as you can see here, most of the scores have changed between 0 and plus 10%. And this is mainly due to the indirect oil and gas inputs, like, for example, for heat from natural gas, which is used in many chemical production data sets, but also due to other updates, like, for example, in the electricity supply. And the decreases in scores can mainly be explained by remodeling of technologies and updates in prices affecting allocation factors and so on. And the high increases on the far right in this diagram are linked to products with a direct input of natural gas or petroleum, like, for example, the petroleum refinery outputs. But it's really important, and we want to really emphasize this here, that some key building blocks for petrochemicals and polymers like ethylene and propylene, they're still based on older aggregated industry LCIs. And this, unfortunately, they are not affected by the update, and new data for these key products are planned for upcoming releases, and that will be specifically then the introduction of a steam cracker process, which we hope then to have ready and available in version 3.10 of the database. So wrapping up with a brief discussion of what we see are some important aspects to keep in mind when working with this update, and also a bit of an outlook for what we want to do next. So as I indicated with the comparison to Masnadi et al., we still need to analyze the supply of unconventional oil and gas in more detail. And also, as Niels indicated, we still have the transport of crude oil, but especially liquefied natural gas by tanker, as it was in 3.8, and this is an area where we definitely need to work and include updates in coming versions. We did not update oil spills for long-distance pipelines for crude oil over 3.8. This is also an area where we can work more. And as I just said on the previous slide, we don't have the changes in oil and gas supply fully propagated to the feedstocks for petrochemicals and plastics. This is an important limitation. And we also don't have a dedicated modeling approach for consequential supply of crude oil and natural gas in 3.9. But here we need to consult the relevant experts to really find the most appropriate model for ecoinvent. And as an outlook, we hope to be able to add or reintroduce geographies for production. This will be especially relevant to improve the supply mixes in important economies like China, Japan, but also in certain countries in Latin America. The producing countries have now production mixes, domestic production mixes, but in some cases we also for those countries need to consider imports to have the markets for natural gas representing consumption mixes in these countries. And as I just said before, we definitely need to take a closer look at the tanker ships to have a better representation of the impacts from transport of LNG and crude oil. We will continue comparing how these results stack up against other sources. We just had the climate trace inventory released last week, and all of these give us very good reference points to compare how our modeling is in line with other global data sets. So this will be a continuous work that we will look forward to carry on. And finally, we need to come together in international multi-stakeholder dialogues to figure out some of the key methodological and also data-related aspects to have the most consistent representation of oil and gas supply in LCA. And this is obviously something ecoinvent cannot solve by itself. So we look forward to engage with the relevant dialogues to take this forward as well. So with that, I come to the end of my presentation,